Hi there, students. Welcome back to geometry. This is Mrs. Brunk again. In this next module that's upcoming, and actually the next, we are going to be shifting our focus away from lines that are parallel or perpendicular and angles that are formed by lines intersecting. We're going to shift over into looking at triangles. And we're going to be exploring what it takes for two triangles to be considered congruent. Okay? And we're going to learn lots of different ways to show that triangles are congruent. But in today's lesson, we're just going to explore triangle congruency. And here's our learning goal. We will be able to show and explain what makes two triangles congruent. Now, we're going to find out later on that there's some shortcuts for this, and that's actually for later lessons. But in this lesson, we're going to learn what would absolutely guarantee that two triangles are congruent. And if you think about it, triangles are made up of three angles and three sides. So you would think they would absolutely have to be congruent if all the angles were the same measure in two triangles and all the side lengths were the same, right? So all six parts, three pairs of angles, three pairs of sides in two triangles, if they're the same measurements, then they would have to be congruent, which is just another way to say equal. So you can apply what you've learned about corresponding parts of congruent figures to write the following statement about triangles. So remember we learned the CP-CFC theorem that said if two figures are congruent, then all of their corresponding parts would have to be congruent. So, if two triangles are congruent, so we're going to kind of adapt that CPCF and we're going to call it CPCT instead. So, corresponding parts of congruent triangles instead of congruent figures are congruent. So, if two triangles are congruent, then the corresponding parts of the triangle are congruent. The statement is, again, sometimes referred to as the CPCTC. And then we're also going to show that the converse of that is as well true. In other words, if all corresponding parts of two triangles are congruent, then the triangles must be congruent. So remember, the converse means we just reverse the if part and the then part. And we're saying that the CPCTC is actually true both directions, so both the converse and the original. So knowing that all the parts are congruent means the triangles themselves are congruent and vice versa. So, two triangles are congruent if and only if corresponding parts of sides and corresponding pairs of sides and corresponding angles of the triangle are congruent. That actually says these two things, these two statements together. So instead of having to have two separate statements, one being the original and one being the converse, as we did with those properties and things we learned in the last module, we're this time going to just use what's called a biconditional. So instead of saying if triangles are congruent, then all the parts are congruent, and then also if corresponding parts of two triangles are congruent, then the triangles are congruent, we're just going to say this. Two triangles are congruent if and only if corresponding parts of the sides and corresponding pairs of angles are congruent. So again, the if and only if sounds really strong, right? This is the only way it's true. That's a way we'll state a theorem when it works both ways, and we call that biconditional. So biconditional, meaning that the statement is true both directions. To decide whether two triangles are congruent, you can compare the corresponding parts. If they are all congruent, then the triangles are congruent. If any of the corresponding parts are not congruent, you can use that theorem also to say, well, then the triangles aren't congruent. So you can also use it to prove that they're not congruent. It's such a strong statement, it works to prove things are congruent, also proves to, can be used to prove things are not congruent. So let's take a look at a pair of triangles that we think they look like they might be congruent in example A. So all I have to do is go through and see if I can match up three pairs of matching sides and three pairs of angles. So let's see, this angle, or this side right here, JH, is 1 meter, and here I have one here. That's 1 meter. So it looks like JH and ML go together. Okay, let's look at another pair of sides. So now these sides, This side is 2 meters, and over here, this side is 2 meters. So it looks like GJ and KM are congruent. And then the third pair of sides, let's see, let's go green here. They're both 1.7. And so we know that all 3 pairs of sides are congruent. Now how we, oftentimes instead of maybe using colors, if we don't have colors available, is we'll use matching marking. So like this first pair, I would have put a single pair of tick marks. On the second pair, I might have put 2 tick marks. And on a third pair, I'd put, 3 tick marks. 3 tick marks on this one to match up with 3 on this one. So you can do this with colors, or you can do this with markings that are matching. Okay, so we know that the sides are all congruent. Now what about the angles? Okay, so let's see. So I can see, and I'll use that marking thing on the angles. I can see that there's an angle here that's 60 and one here that's 60. I can see that there's this right angle here and a right angle here, so those are congruent. And then the third pair of angles, they're both 30 degrees. So I've matched up all 3 pairs of angles that are congruent and 3 pairs of sides. So now we can say that these triangles are congruent. Now we'll be asked then to write a congruent statement. And a congruent statement, remember, has to go in the order of vertices. So let's say I call this first triangle GHJ. So say I start at G, go to H, and then J. So notice I went along the green side from G to H. So that means on the other triangle, I'd have to start at K and go to L. Okay? So I'd say K, L, M. Now sometimes it's easier if you just look at the angles, like angle G is 30 degrees, well angle K is 30 degrees, so G has to go with K, H is the right angle and so is L, L would have to go with H, and so on. So sometimes it's easier just to look at the angles first in order to write that order of vertices statement, okay? So that kind of models what we are trying to do to verify. We're going to make sure we have 3 pairs of sides congruent, 3 pairs of angles congruent, and then we'll write a congruent statement. Oops, I wrote a similarity statement. I meant to say congruent. I don't know, I missed the rest of the symbol there. So let me just recap how this symbol, it's like we're saying they're equal, but then we put a little squiggle over the top and then we read that as congruent. So sorry I made the wrong statement or symbol there. That symbol I actually wrote actually means similar. I meant to say congruent. So let's take a look at B. So with B, let's see, I've got a pair, I'm going to start with the angles first. There's a 71 degree angle here and one here. Oh, and then there's another one over here and another one here. These 2 triangles are called isosceles triangles. They have actually 2 pair of angles that are the same. So, and then there's this angle up here that's 38 degrees, and those are equal. You can tell by the markings on the sides that this side, this side, this side, and this side are all the same. So we actually have, we could say this side, and it doesn't matter really which ones we match up because they're all equal. And then you can see from the markings, see these? Those are equal. So we have a little bit of flexibility on how we write the statement this time, because when you have more than one pair of angles that are the same measure, you know, maybe R is going with U, but maybe R could also go with W. So when we write our statement, we have a little bit more flexibility. So maybe I would say this is triangle, and I'll start with and say RST, because I like the way that that goes in alphabetical order. And then congruent to, so now I got to find one of the angles that's the same as R. So maybe I'll go to U, and then I went from the 71 degree angle to the 38 degree angle, so I'll have to do that here. So if I start at U, I'll have to go to VW. And those are congruent. Okay, so let's look at this next one. So I see a side that's 7.9. And then over here one that's 7.9. So technically I could mark them like this, matching sides. Okay, then over here I have a side that's 8.5, but then over here, look, that's not 8.5. So right away I can tell I'm not going to be able to match these up, because even though I have two pair of sides that are equal, I could have even said these 12.1 centimeter sides are equal, but the third pair of sides are not the same. And I don't even know anything about the angle measures, so I certainly could not do that with the information I have right now, be able to say they were congruent. But I actually know enough information to say they are not congruent, because not only do I I don't just have enough information, not enough information to tell they are congruent, but I actually have the information to say they are not congruent. And that's because, look, they have these sides that are different. They're close, but close is not congruent. And then we can do the same thing with this next triangle. So see, there's a 79 degree angle. Over here, the closest we can come is 78. So again, not congruent. These are not congruent triangles. Okay. So in example 2, it says find the value of the variable that would result in congruent triangles. Well, looking at example A, I can see that there's a 45 degree angle there and a 45 degree angle there, that those should be congruent, right? Then I have a pair of 55 degree angles right here, right? I've got all these matching sides. There's a side here that's marked with a single tick mark, and there's one. That's a pair, right? 2 and 2. And then there's 3 markings, and then 3 over here. So all the sides are congruent, and I've got 2 pair of angles congruent. So in order for the triangles to be congruent, this third pair of angles would have to be the same. Now this one is labeled as 5x plus 30, but this one isn't labeled at all. But in fact, I know that angle L has to be the rest of 180 degrees. Remember, the 3 angles in a triangle add up to 180. So if I have a 55 degree angle and a 45 degree angle, and I take them away from 180, that leaves me with 80 degrees left. And so for these triangles to be congruent, this 5x plus 30, which is angle P, must equal to angle L, which is 80 degrees. So that's my equation I can solve. Subtract 30 to find out what x is. Gives me 5x equals 50. And then divide by 5. I know that x has to be 10. Okay, so they asked me to find the value of x that would make the triangles congruent, and I did. X must be 10, so that when I substitute that in here, I'll get 80 degrees. That matches up with the other triangle. Okay, so let's go ahead and designate B a U-try question. So I want you to go through and verify that all the other parts are congruent, and then see if you can use the information to find out the value of x that would guarantee that these angles B and E would be congruent. So pause the video now and give problem B a try. And in order for those 2 triangles to be congruent, angles B and E would have to be the same measure, which is 43 degrees, and that means x would have to be 26. Okay, let's move on and take a look at another example. What about if we're working with sides instead? So we can see in these triangles that they've marked 3 pair of angles congruent. You can see they've marked angle A congruent to angle D. They have angle C with 2 markings, and that's over here the same as angle F. And then you can see angle B is marked with 3 arcs. So that's matching up here with E. So we know the angle pairs. All 3 angle pairs are congruent. We've got that down. So that's good. So now let's look at the sides. So we've got one side here that's 50 and one side here that's 50. We have one side over here that's 30, and then one over here that's 30. So we've got 5 pair of parts congruent. So we just need to show that that third pair of sides right here, this side and this side, are going to be the same. So we know in order to be the same, 2y plus 20 would have to equal 36. So all I have to do to solve there is to subtract the 20 Okay, and that leaves me with 2y equals 16. And then divide by 2 leaves me with y must be 8. So they wanted me to find the value of the variable that would make the triangles congruent, and I did. If y was 8 and I substituted that in here, that would make that side 36, and then that final pair of parts would be verified as being congruent. Okay, so here's one for you to try. So take a look at and make sure that all the parts, you can match up all 5 pair of parts that are actually given as congruent, and then see what value of the variable y would make it so that final pair of parts would be congruent and they're in the triangles congruent. So pause the video now and give example D a try. Okay, thanks for giving that one a try. And your value of y that would make those two sides congruent, and therefore the triangles themselves congruent, would be y equals 5. So that actually does it for today's lesson. And we, in future lessons, will learn some shortcuts. But right now, it's really just a matter of we have to work our way through the triangles and show that all 6 pair of parts are congruent. And then we know for sure the triangles are congruent. Thanks for coming to class.